everyone, welcome back to my channel. For today's lesson, we will be having adding and subtracting rational algebraic expressions. We have learned from the past lessons how to multiply and divide rational algebraic expressions. Maybe you're confused why multiplication and division were first taught than addition and subtraction. However, in rational algebraic expressions, multiplication and division are sometimes taught first because these operations are easier to perform than addition and subtraction. Addition and subtraction of rational expressions are not easy to perform as multiplication because, as with numeric fractions, the process involves finding common denominators, or the LCD. By working carefully and writing down the steps along the way, you can keep track of all of the numbers and variables and perform the operations accurately. Let's start. In adding or subtracting similar rational expressions, add or subtract the numerators and write the answer in the numerator of the result over the common denominator. In symbols, a over b plus c over b equals a plus c all over b, where b is not equal to 0. Let's add and subtract similar fractions. Our given is 1/2 plus 3/2. Copy the common denominator and then add the numerators. Our numerators are 1 and 3. So 1 plus 3 all over 2. Or 1 plus 3 is 4. Copy the denominator. We have 2. So we have 4 divided by 2 is simply 2. Therefore, the sum of 1/2 and 3/2 is 2. Next, we have 3/5 plus 7/5. Add the numerators. We have 3 plus 7. Copy the common denominator. We have 5. 3 plus 7 is 10. Denominator is 5. 10 divided by 5 is 2. The sum of 3/5 and 7/5 is 2. Another example, we have 9 over 4 plus 5 over 4. Add the numerators. 9 plus 5. Copy the common denominator, 4. 9 plus 5 is 14 over, denominator is 4. 14 and 4 have GCF of 2. So we have 14 divided by 2 is 7. 4 divided by 2 is 2. Or we have 7/2. 7/2 can be written or simplified as 3 and 1/2. Next, we have 6 over x plus 5 plus x plus 2 all over x plus 5. Again, add the numerators. We have 6 plus x plus 2 all over common denominator is x plus 5. Then, add the similar terms in our numerator. Similar terms in our numerators are 6 and 2. So we add 6 and 2 and their sum is 8. So for our numerator, we have x plus 8. Our denominator is x plus 5. Therefore, the sum of 6 over x plus 5 plus x plus 2 all over x plus 5 is x plus 8 all over x plus 5. Next, we have x squared minus 2x minus 7 all over x squared minus 9 plus 3x plus 1 all over x squared minus 9. Again, we are still in similar fractions. All we have to do is add our numerators. So we have x squared minus 2x minus 7 plus 3x plus 1 all over x squared minus 9. And then add the similar terms. We have x squared. So in our numerator, there is no term similar to x squared. So we will just copy x squared. Next, we have negative 2x and positive 3x. They have unlike signs, so we have to subtract them. So 3 minus 2 is 1, and then get the sign of the bigger number. So that is positive. So we have positive 1x or simply positive x. Next, we have negative 7 and positive 1. They are similar since they are both constant term. Negative 7 plus 1 is negative 6. Again, they have unlike signs. Negative and positive, so subtract and then get the sign of the bigger number, and that is negative. After that, copy the common denominator. We have x squared minus 9. Next is getting the prime factor of our numerator. First, do not forget to check if the terms in our numerator have common monomial factor. If there is none, factor it then. So factors of x squared plus x minus 6 is x minus 3 times x plus 2. Next, our denominator, we have x squared minus 9. This is an example of sum and difference of perfect squares. So we have square root of x squared is x, square root of 9 is 3. 1 is negative, 1 is positive. And then, simplify the factors or the prime factors. So we will cancel x minus 3 and then get the remaining factors. So we have x plus 2 all over x plus 3. Therefore, the sum of x squared minus 2x minus 7 all over x squared minus 9, 3x plus 1 all over x squared minus 9 is x plus 2 over x plus 3. Next, we have x squared minus 2x plus 3 all over x squared plus 7x plus 12 minus x squared minus 4x minus 5 all over x squared plus 7x plus 12. Our given is similar fraction because they have similar denominator. Copy the common denominator, then simplify the numerators. So we have x squared minus 2x plus 3, and then since we have subtraction as our operation, the terms after the subtraction will change its sign. So x squared is positive, it will become negative. Negative 4x will become positive 4x, and negative 5 will become positive 5. So we will have for our numerator x squared minus 2x plus 3 minus x squared plus 4x plus 5, and then copy the common denominator, x squared plus 7x plus 12. The changing of the sign is only applicable if and only if our operation is subtraction. Only after the subtraction will change the sign of our terms. Now we can simplify the numerators, add similar terms or subtract similar terms. So we have x squared and negative x squared. Since they have unlike signs, we will cancel them. Their sum or their difference is 0. Next, we have negative 2x and positive 4x. Since they have unlike signs, we will subtract them. So, 4 minus 2 is 2. Then copy the variable. So, we have 2x and then copy the sign of the bigger number. So, we have positive 2x and then we have positive 3 and positive 5. They are similar terms because they are constant term. They also have similar signs or same sign, so we will add them. 3 plus 5 is 8. And then copy the common denominator. We have x squared plus 7x plus 12. Do not forget to check if our answer is in lowest term. 2x plus 8 have common monomial factor. Their common factor is 2. So 2x divided by 2 is x. And 8 divided by 2 is 4. So we have 2 times x plus 4. All over, factors of our denominator, we have x plus 4 times x plus 3. And then our favorite part is the cancellation. So cancel x plus 4 and then copy the remaining factors. We have 2 over x plus 3. Therefore, the difference of our given is 2 over x plus 3. Next, let's add and subtract dissimilar fractions. When we say dissimilar fractions, these are fractions who have different denominators and cannot be add or subtract immediately. Let's have our first example. We have 1/5 plus 1 over y. First, find the least common denominator. To find the LCD of our denominators, we will get the only factor of them other than 1. The first denominator is 5. The only factor of 5 other than 1 is 5. And the only factor of y other than 1 is y. After getting them, we will multiply and then 5 times y is 5y. Therefore, our LCD is 5y. We will divide our LCD by our denominator. So, 5y divided by 5 is y. Multiply to our numerator, y times 1 is y. Next is 5y divided by y is 5. Multiply it to our second numerator, that is 5 times 1 is 5. Then, copy our LCD. Do not forget to check if you can still factor your answer. If you cannot factor your answer, therefore, it is already our final answer. The sum of 1/5 and 1 over y is y plus 5 all over 5y. Next given, we have 2 over x squared minus 3 over 7x. To get the LCD, the factors that appear in the denominators are 7 and x. List each factor with its highest power. Variable x has highest power of squared. Therefore, we will get the highest factor x squared. then multiply it to 7. Therefore, the LCD is the product of x squared and 7, and that is 7x squared. Next, we will divide the LCD by our denominators, that is 7x squared divided by x squared. The quotient will be multiplied to our numerator. So the quotient of 7x squared and x squared is 7 times 2 is 14. Next, 7x squared divided by 7x is x times 3 is negative 3x. Do not forget to check the sign of the second numerator. And then copy our LCD, that is 7x squared. Do not forget to check if we can still have the lowest term of our answer. Therefore, our answer is 14 minus 3x all over 7x squared. Or, you can have negative 3x plus 14 all over 7x squared if you are going to follow the standard form. Next, we have 1 over 18x cubed y minus 5 over 27x squared y cubed. How are we going to get the LCD of our denominators? If you are having a hard time getting the LCD, let us have it slowly. Let us have first 18. Factors of 18 are 9 and 2. Factors of 9 are 3 and 3. 3 times 3 times 2 are already prime factors of 18. Next is 27. Prime factors. Let us have 9 and 3. 9 is still not prime, so prime factors of 9, 3 and 3. 3 times 3 times 3 are prime factors of 27. List them down. So 18 have 3 times 3 times 2, or we can have 3 times 3 as 3 squared. So 18 will have 3 squared times 2. Next, we have 27. Prime factors are 3 times 3 times 3, or we can simply write 3 times 3 times 3 as 3 cubed. Aside from our numbers, we have the variables x and y. Again, get the highest power of our factors. So for our x, highest factor in our denominator is x cubed. Next, highest power of y is y cubed. So the factors that appear are 2, 3, x, and y. Again, get the highest powers of each of these factors. First factor, we have 2. There are no other 2 in our prime factor. And then, highest power of our 3 is 3 cubed. And then, highest power of x is x cubed. Highest power of y is y cubed. Multiply those factors. So, we have 2 times 3 cubed times x cubed times y cubed will give us 54 x cubed y cubed. Take note of our LCD. So we will divide our LCD by our first denominator. So prime factors of our LCD and prime factors of our first denominator. Simplify them, cancel, and then multiply the remaining factors we have 3 times y, 3y squared. For our denominator, nothing left, so we have 1, or simply 3y squared. Then multiply it to our first numerator, that is 3y squared times 1. After that, let us have the quotient of our LCD and the second denominator. So we have the prime factors again of our LCD and our second denominator. Cancel. And then multiply the remaining factors. So we have 2 times x is 2x. Nothing's left in our denominator. Therefore, our denominator is 1. So we have 2x over 1, or simply 2x. So the quotient will be multiplied to our numerator. So we have 2x times 5. Copy first our LCD. We have 54 x cubed y cubed. And then simplify our numerators. 3y squared times 1 is 3y squared. Next is 2x times 5 is 10x. Take note of our operation. Do not forget to check if our answer has common monomial factor. If there is none, therefore, it is already our final answer. The difference between 1 over 18x cubed y and 5 over 27x squared y cubed is 3y squared minus 10x all over 54x cubed y cubed. Let us have more examples. 7 over 3x squared minus 6x minus x squared over x squared minus 4x plus 4. As you notice, our denominators can be factored. Before we factor, copy our numerators. We have 7 and x squared. Factors of 3x squared minus 6x are 3x and x minus 2. Factors of x squared minus 4x plus 4, we have x minus 2 times x minus 2, or we can write this as x minus 2 squared. Observe our denominators. The factors in the denominators are 3, x, and x minus 2. List the highest powers of each of these factors. So we have 3x times the square of x minus 2 as our LCD. Next, copy our LCD and then LCD divided by our first denominator, we have x minus 2. Multiply it to 7, so we have 7x minus 14. Next is LCD divided by the second denominator. Multiply it to our numerator. So the quotient of our LCD and the second denominator is 3x times x squared. So we have negative 3x cubed. Or if we can rewrite this in standard form, we will have negative 3x cubed plus 7x minus 14 all over 3x times the square of x minus 2. For your activity, perform the indicated operations for each given. Always follow the steps on how to add or subtract rational algebraic expressions. You can always go back to my video to check the steps that we have in our discussion. Thank you for spending your precious time learning with me today. I hope you are now ready to answer any kind of operations for rational algebraic expressions. See you on my next video. Bye!